Okay, looking through our exam, 7E. I gave the question with a picture of the roots, the ninth roots of unity, and that was meant to be a hint to start off with. Z to the power of 9 is 1, bring it over, and then you should use this factorization. A lot of people struggle with this question, I think, because they didn't connect the ninth roots of unity to the question. Therefore, the solutions to z to the 6 plus z to the 3 plus 1 is equal to 0. They are the ninth roots of unity, except we remove all the cube roots of unity. Okay, so you can either look at the diagram and remove the 3 cube roots of unity, or you can work out all of the ninth roots of unity and just remove the 3, work out the cube roots of unity and then remove the 3. I wanted it to be, I only made it a 1 marker. I wanted it to be a bit easier. It proved a little bit more difficult. That's missing an eye. Okay, next. Part 2. Okay, there was a typo in the question, and the net result is everyone got the 2 marks awarded. However, I do want to go through this question because very few students were able to get it out or know how to proceed in order to do it. I'm going to show you, there's more than one way. I'm going to show you probably what I think is the best way. So you've got your 6 answers there. You can write it in factored form. And then we use the fact that z minus alpha times z minus alpha bar is z squared minus twice the real part of alpha times z plus the length of alpha squared. And therefore we can factor into 3 quadratic factors here. Getting that far was the second mark. And then what you needed to realize is that if I want a 1 minus cos in each bracket, because there's a coefficient of 2 there, I really want a 2 minus 2 cos. Then I can factor out the 2. So the trick was to sub in z equal to 1. And when you do that on both sides, when you sub in z equal to 1, you get this expression here, and then you factor out a 2 from each of the 3 brackets. And that becomes 2 to the power of 3, which is 8, and therefore the answer, you get the answer as required. Now, on your exam paper, there was a typo. It said a half instead of 3/8. So the net result was Miss Najim and I agreed we give the full 2 marks to every student. But that was a very interesting question and one you should know how to do. So moving on, question 8. This was done really well. You expand using your binomial expansion. Okay, just be careful with your i's and I squareds and I cubes and so forth. And then you put the real bits at the front, the imaginary bits at the back. You equate imaginary parts, second mark for equating imaginary parts properly. And then you need to expand and show all your steps of working out. That was the third mark. Okay, that was done quite well. This one here, you needed to rearrange the equation, and then you let x be sine theta. Now, a lot of people seemed to jump this step and forgot what x equals to, and that affected their answer down here. Like a lot of people put things like cis or cos rather than sine of the angle. So just something to be wary of. Don't forget what you're using your substitution, what substitution you use. First mark was for getting to this stage where you got sine 3 theta is negative 1 on root 2. This has answers in quadrant 3 and 4. So you start producing answers, and then you get answers for theta. Now, if you wrote the first 3, a lot of people wrote this as their answer. The only problem is that sine 5 pi on 12 has the exact same value as sine 7 pi on 12. They're not distinct. We're looking for 3, because it's a cubic, we're looking for 3 distinct roots. You actually needed to go to the next one. So ignore one of those answers and go to the next one, which ends up being sine 5 pi on 4, which has an exact value of negative 1 on root 2. I accepted, even if you didn't work out the exact value, but if you worked out that third root, then having that third root distinct was the third mark. So 1 mark here, 1 mark for working out your angles, and then 1 mark for the final answer. Okay, 8b, this was poorly done. A lot of people struggled with tiny little mistakes and the concept or how to approach the question. A couple of people did a couple of different things. Some people used Pythagoras' theorem and it didn't really help them in the question. You want to, when you approach a question like this, you want to think, what is the simplest way in order for me to do this question? That's what you need to think. So the simplest way of thinking is by considering, we want to work out D, and you know A and C, and thinking about how is this connected. Okay, so the obvious one is if you take the vector from D to A, you rotate it 90 degrees clockwise and you make it 3 times larger, then you get DC. So because it's a clockwise rotation, you had to times by negative I. That was a common mistake. People forgetting times by negative for the clockwise rotation. So you needed this. Some people went the other way, started from DC, rotated 90 anti-clockwise to give you AD. So you could have written the vector dA is equal to 1/3 I DC. That also would have got you the first mark. So an correct expression involving AD and C only, not involving B, because B wasn't given to you, that was worth the first mark. Okay, using the fact that the vector from D to C is the OC, position vector of C minus position vector of D, and dA is position vector of A minus position vector of D. You get this expression. I manipulated it a little bit before I substituted in what C and A was. And you should eventually get to this here. So making D the subject and having just numbers, that was worth the second mark. And then I proceeded by timesing top and bottom by the conjugate and then simplifying. So realizing properly, timesing by top and bottom by the conjugate, that was worth the third mark. There was carried forward previous error here. Another way that was commonly done by a lot of students was that they let D be x plus iy. So for example, from this line, if you follow down here, you get to this stage, you expand, and then what you do is you equate the real part and you equate the imaginary part. And if you got 2 correct equations here, that would be the second mark. And then keep on simplifying, you get the same final answer, third mark. Okay, the last question. The first bit was done quite well. So if you take the vector z3 minus z1, there's a vector starting from z1 and going to z3. It's that vector there in blue. And the other vector is z2 minus z1, which is starting from z1 and going to z2. So if you take that vector and go pi on 3 anti-clockwise, you get to that one. So that's why it's e to the I pi on 3, rotate pi on 3 anti-clockwise. So therefore the final answer in mod arg form, it asked for mod arg form, was cos pi on 3 plus I sine pi on 3, 1 mark there. Part 2, I want to talk about part 2 because I marked slightly leniently. A lot of students gave the answer of negative cos negative pi on 3 plus I sine negative pi on 3. Now please note that this is not mod arg form. Okay, modulus argument form, the R value must be positive, so that having a negative 1 there is not correct. Okay, you're allowed to have a negative argument, okay, but you can't have a negative modulus, so that is not actually technically mod arg form, but it was equivalent to the final answer, so I was lenient, and if you wrote an equivalent answer, even if it wasn't in mod arg form, I still paid the mark for part 2. What I wanted you to see was that this z2 minus z1, you could chuck it on the outside here because that's still the same direction and same magnitude. You can rotate that by 2 pi on 3 to get to the vector starting from z2 and going to z3, which is z3 minus z2. That's a 2 pi on 3 anti-clockwise rotation. So the answer I was looking for was cos 2 pi on 3 plus I sine 2 pi on 3. But I did mark leniently. If you gave me something equivalent to that, even if it wasn't in mod arg form, I still paid the mark. Third part, this was done pretty poorly. What I was looking for was, because in part 1 and part 2, you had a connection here and a connection here. And these, if you look very carefully, matched up very, very, very well. The denominator here was this bit, and then the numerator of this is here, and the numerator of this one's here. The clever trick you can do is you can factor out a 1 on z2 minus z1, and then you get in brackets 1 minus, and then this bit here is your answer from part I, and this one here is your answer from part II. You substitute in 1 mark for realizing that, for getting to that stage. Bring that up the top, bring that up the top, and because the modulus is 1, just the argument becomes negative, and then you get this expression here, and you just start simplifying, make everything get acute angles, and things cancel out nicely, and you get left with this, 1 minus 2 cos pi on 3, and then you can work out cos pi on 3 as a half, and that all becomes 0. And the second mark was for showing the rest of that question. Okay, I hope you found that useful. All the best with all your holiday homework, and have a good holiday. We're not going to have much time to go through this exam at all when we get back. It's going to be get back into work straight away, period 0, first day back, 6th of Feb. See you then.